Here I have a preview of the nebula volumetric effect that I wrote. Over here, I have parameters that I can vary that change the output of the rendering. During the test, I varied these parameters and gauged how they impacted the performance of the shader. These are the scripts that I use to orchestrate these tests. This first one keeps track of how long each test runs for, and for this demo I'm going to use 1 second to keep it short. Also can be told how many tests to run. In this case it gets driven by this other script. It also can be configured in how many samples to use per average, how many samples to take per second, and how long to wait for Unity to finish loading before beginning the tests. I also have a script that moves the camera so I get a better feel of the average performance, because it's not going to be constant as the camera moves throughout the noise field. And then I have this script here, which takes a base setup of the material, which has a bunch just basically default parameters for the material, for the effect, and how many parameters to vary, which ones to vary, and to what value. So this will generate 2 to the 4 variations where each of these changes is either applied or not to the base material. So there's some value for each of these parameters, and then it changes it from that value to the value listed here. So when I start it, the test will wait for Unity to finish loading, and then begin running through each variation and recording the time it takes per frame. Once it's done, it plays an alarm sound to let me know that it's finished, and dumps the data for the test out to a file. So now that it's done that, it will have spat out these files, and if I open that up, this has the summary of each test, what the averages were with the smooth average samples or the raw samples. I did this frame rate smoothing to get a better feel for what the average really would be with running fewer samples. And then it dumps out those smooth averages out to this file as well, which is set up in such a way that I can take it straight in to this file and throw it through the analysis. So back in here, I'll load that averages file and run it through my analysis script, and that generates the sign table of the appropriate size and multiplies the data through it, and then does the division and whatnot. And with that test, it says group B by itself accounted for almost 40% of the variation. So that would be this cloud noise factor parameter. This group D by itself is just this fullness parameter. And then when it varied 2 parameters, say B and C, let's talk about these two, cloud noise factor and surface level, both changed. This is the process that I used to automate the collection of performance data and the analysis of performance data.